Hello everyone, my name is Adelia Stefani and my friends Eva Caroline and Chinico Cofely. We are from University of Kristen Krida Wacana Civil Engineering 2020. In this video, we would like to tell you about the structural of water resources. And the structural of water resources that we like to tell is about Hoover Dam. So let's check it out. Okay, first, what is Hoover Dam? Hoover Dam is one of the largest dams in the world, located in Black Canyon on Colorado River at the Arizona-Nevada border, United States. Originally, Hoover Dam, known as Boulder Dam, from 1933, it was officially renamed Hoover Dam for President Herbert Hoover by a joint resolution of Congress in 1947. Hoover Dam was built in 1931 until 1936. The cost to build this dam is around $165 million, and this dam owned by the United States government. The type that they use to build this dam is concrete gravity arch. The height of Hoover Dam is 726.4 feet, the length is 1,244 feet, the elevation at crest is 1,232 feet, width for crest is 45 feet, width for the base is 660 feet, and the volume is 3,250,000 cubic yards.
Sorry, Adele, can I ask, what is the reason for build this dam?
Okay, Eva, thank you for your question. So, what is the reason for build this dam? I will explain it in the next slide. Okay, this is the reason why the Hoover Dam was built. The Colorado River is considered to have a good potential because the river has good flow power. So, U.S. government is trying to divert the river for irrigation purposes. The government instructed the Bureau of Reclamation to come up with a solution to build world's largest dam. Initially, Arthur's Chief of Service, Paul Davis, proposed using dynamite to tear the walls of Boulder Canyon, 20 miles north of the dam site, into a river. However, after considering it for several years, the Reclamation Service finally rejected the proposal, citing doubt about unproven technique. In the report, Davis proposed to build a dam near the Boulder Canyon, but the Bureau considered the location not good because the location was too narrow for construction. And finally, the service decided to build the dam in Black Canyon because they found it ideal, and a railway could be laid from the railhead in Las Vegas to the top of dam site. Before the project was carried out, there were a few uptails where the location of Black Canyon was included in several states. So a Colorado attorney, Dale Carpenter, proposed that the 7 states which fell within the river's basin include California, Nevada, Arizona, Utah, New Mexico, Colorado, and Wyoming, form an interstate compact with the approval of Congress, and the resulting Colorado River Compact was signed on November 24, 1922. Legislation to authorize the dam was introduced repeatedly by 2 California Republicans, Representative Bill Swing and Senator Hiram Johnson. But representatives from other parts of country considered the project as hugely expensive and one that would mostly benefit California. But on the other side, the 1927 Mississippi flood made Midwestern and Southern congressmen and senators more sympathetic about the dam project. It is because the St. Dam Francis, which has the same time as the Hoover Dam, experienced a failure which caused a flood that killed 6,000 people, so they against that the safety of the dam construction could not be guaranteed. Congress authorized a board of engineers to review plans for the proposed dam. But the Colorado River Board found the project feasible but warned that if the dam failed, every downstream Colorado River community would be destroyed, and that the river might change course and empty into the Salton Sea. The board continued, to avoid such possibilities, the proposed dam should be constructed into conservative, not ultra-conservative lines. So, on December 21, 1928, President Coolidge signed the bill authorizing the dam. The Bordeaux Canyon Project Act appropriated $165 million for the Hoover Dam. Next slide. And for the design. The type of dam that decided to use is a large concrete gravity dam, and the design was overseen by Bureau Chief Design Engineer John L. Savage. The monolithic dam would be thick at the bottom and thin near the top, and would present a convex face toward the water above the dam. The curving arch of the dam would transmit the water's force into the abutment, in this case the rock walls of the canyon. The wedge shape that would be 660 feet or 200 meters thick at the bottom, narrowing to 45 feet or 14 meters at the top, leaving room for a highway connecting Nevada and Arizona.
Next is about construction process of Hoover Dam. The first one is about labor force. At that time, there was a very large workforce that wanted to participate, and it was divided into groups. The first one were squatters who were called McKeever's File, and the second one is Williams File or Ragtown. They live on the flats along the Colorado River, and the third one is River Camp, which temporarily live in a bunkhouse that attached to the canyon wall until the Boulder City is complete. Then along the construction process, there were two problems with the workers. The first is caused by industrial workers of the world that hope to unionize the six companies' work by capitalizing on their discontent. This made Crow, the general superintendent of the job, gave a scathing interview of a newspaper describing the workers as malcontents. The second is about labor action that took place in July 1935. As construction on the dam wound down, when a six companies manager altered working times of forced workers take lunch on their own time, workers responded with strike. After that, Crow River sold the lunch degree and the workers raised their demands to include a $1 per day raise. The company agreed and the strike ended. The second one is about river diversion. Next slide. So before the dam could be built, the Colorado River needs to be diverted away from the construction site. To accomplish this, four diversion tunnels were driven through the canyon walls, two on the Nevada side and two on the Arizona side. These tunnels were 17 meters in diameter. Their combined length was more than 5 kilometers. The contract required these tunnels to be complete on 1 October 1933 with a $3 per day fine to be assessed for any delay. To meet the deadline, six companies had to complete work by early 1933, since only in late fall and winter was the water level in the river low enough to safely divert. Workers used 500 pneumatic drills, hoses, and compressors to make a holes in the canyon rock where explosives could be placed. Once holes were drilled, workers used dynamite and to blast into the rock and break it into smaller pieces that could be hauled away by dump truck. A ton of dynamite was required for every 5.3 meters of tunnel that was dug into the canyon wall. Special teams then visit the inside of the tunnel to ensure it would be remain safe for workers to work inside it. The tunnels were then lined with concrete and by sliding sticks of dynamite into holes bored into the canyon wall. Workers were able to blast and excavate large diversion tunnels. These tunnels, each about the size of a 4-lane highway, and were lined with 3 feet of concrete. The third one is about groundworks, rock clearance, and growth curtain. Next slide. With a short explanation, the groundworks that referred here were two cover dams that construct to, to protect construction sites from the Colorado River. When the cover dams were in place and the construction site was drained of water, excavation of the dam foundation can be begun. For the dam to rest on soil rock, it was necessary to remove accumulated erosion soil and another loose materials in the riverbed until sound bedrock was reached. So this is the rock clearance stages. Finally is the growth curtain. A growth curtain is a form of a grout that used to reinforce the bedrock foundation which previously has been cleared. This work is done by filling each hole that have been pushed 46 meters into the walls and bottom of the canyon.
Sorry for interrupt, Eva. I
Yes,
want to ask, is there any other function from using growth? Thank you.
yes, there is. Thank you, Adele, for your question. So, the other function is to stabilize the rock to prevent water from seeping past the dam through the canyon rock. And the last is to limit upward pressure from water seeping under the dam. Okay, the next one is about structure and concrete. Hoover dam have an arch shape for deflect the force of the water into the canyon wall through the compression of dam concrete walls using the compression strength of the concrete. The concrete in itself consists of 4 ingredients: sand and crushed rock aggregate, water, and Portland cement. This must be mixed in a proper proportion to yield strong concrete. And the first concrete was poured into the dam on 6 June 1933, but then the concrete heats and contracts as it cures. The potential for uneven cooling and contraction of the concrete posed a serious problem. So, Bureau of Reclamation engineers calculated that if the dam were to be built in a single continuous pour, the concrete would take 125 years to cool down, and the resulting stresses would cause the dam to crack and crumble. This problem was solved by not to pour it in a large quantities, or not to pour it in one single continuous pour. Some as large as 15 meter and 1.5 meter high, and then each 5 foot from contained a set of 1 inch or 25 millimeter steel pipes. So the cool river water will be poured through the pipes and followed by the ice-cooled water from the refrigeration plant. After that, the total of concrete that was used in the dam are about 2,480,000 cubic meters, and more than 5 million barrels of Portland cement and 4.5 million cubic yards of aggregate were into the dam. In addition, there also 850,000 meter cubic were used in the power plant and other works, and more than 937 kilometers of cooling pipes were placed within the concrete. Overall, the dam contains enough concrete to pave a strip 16 feet wide and 8-inch stick from San Francisco to New York City. And then the next one is about dedication and complication. Next slide. The next one is about dedication and complication. With most work finished on the dam itself, except the powerhouse that remained incomplete, a formal dedication ceremony was arranged for 30 September 1935 to coincide with a Western tour being made by President Franklin D. Roosevelt. Although there was a change in time and temperature reaching 39 degrees Celsius, but 10,000 people were present for the president's speech. Then, to mark the occasion, a 3-cent stamp was issued by the United States Post Office Department.
Eva, I want to ask you.
Yeah, what is it?
So, are there any obstacles during the construction process?
During the process, of course, an there is many obstacles. The first one is about the labor action that has a very bad impact, such as a strike. The second one is during the grouting process. This was caused by the workers who did not cast 58 holes. So after the dam was complete and the lake began to fill, large number of significant leaks into the dam. The third one is there was 112 death report as associated with the construction of the dam. Yeah.
So, Eva, what solution that used to handle the growth process?
Solution is to um, to accomplish it by creating a supplemental growth curtain, and it took 9 years to complete it.
In operation, there are four kinds of operation. The first is power plant and water demands. Excavation for the powerhouse was carried out simultaneously with the excavation for the dam foundation and abutment. The excavation of this U-shaped structure located at the downstream zoo of the dam was complete in late 1933, with the first concert placed in November 1933. Filling of lake Mead began February 1, 1935, even before the last of the concert was heard that May. The powerhouse was one of the projects incomplete at the time of the formal dedication on September 1935. A crew of 500 men remained to finish it and other structures. To make the powerhouse roof bomb-proof, it was constructed of layers of concrete, rock, and steel with the total thickness of about 3.5 feet or 1.1 meter, topped with layers of sand and tar. The second is power distribution. The powerhouse was run under the original authorization by the Los Angeles Department of Water and Power and Southern California Edison. In 1987, the Bureau of Reclamation assumed control. In 2011, Congress enacted legislation extending the current contract until 2067, after setting aside 5% of Hoover Dam power for sale to Native American tribes, electric cooperative, and other entities. The new arrangement began on October 1, 2017. The third is spillway. The dam is protected against overtopping by two spillways. The spillway entrances are located behind each dam abutment, running roughly parallel to the canyon walls. The spillway entrance arrangement from classic side flow, where with each spillway containing for 100-foot long, 30-meter, and 16-foot wide, 4.9-meter steel drum gates. Its gates weigh 5,000 pounds, 2,300 metric tons, and can be operated manually or automatically. Gates are raised and lowered depending on water level in the reservoir and flood condition. The gate cannot entirely prevent water from entering the spillway, but can maintain extra 16 feet 4.9 meters of lake level. The fourth is roadway and tourism. There are two lanes for automobile traffic across the top of the dam, which formerly served as the Colorado River crossing for US Road 93. In the wake of the September 11, 2001 terrorist attack, authorities expressed security concerns and the Hoover Dam bypass project was expanded. Pending the completion of the bypass, restrict traffic was permitted over dam. Some types of vehicle were inspected prior to crossing the dam, while semi-trailer truck buses carrying logic and enclosed box truck over 12 meters long were not allowed on the dam at all, and were deferred to US Road 95 or Nevada State Road 163 or 68. The four-lane Hoover Dam bypass opened on October 19, 2010. In 1995, a new visitor center was built, and the following years, visit exceeded 1 million for the first time. The dam closed again to the public on September 11, 2001. Modified tours were resumed in December, and the new discovered tour was addicted the following years. Today, nearly a million people per year take the tours of the dam over by the Bureau of Reclamation. Next, environment impacts. From this construction, there are two impacts, positive and negative. The positive is the dam is used for flood and silt control, hydroelectric power, agricultural irrigation, and domestic water supply. The negative is problem with the water and the riverbed lowering. Okay, how about you guys?
Okay, for me, I think the positive one I want to add, the positive impact is from the tourism. I think this construction is also a major sightseeing destination because almost 1 million tourists go on tours through the dam. So I think this construction have many positive impact.
In my opinion, in every construction, there definitely have a negative impact. The other negative impact here are the ecosystem around it was destroyed and the greenhouse gases was ejecting. That's all.
Okay, everyone, that's all about our discussion and our presentation. Thank you for watching and listening to us. Please like, comment, and share this video. Thank you. Bye.
Bye.